Hello everyone and welcome back to today's session, which is continuation of the previous session in which we discussed about artificial intelligence, machine learning and deep learning, what they actually are. We discussed how AI is a broader field. The machine learning is a part of AI or subset of AI and deep learning is another subset of the machine learning. We also discussed about neural networks, features, labels, and how features and label together make a dataset. We also discussed how the data set is split into training and testing and how the predictions are calculated. And now comes the most exciting part in deep learning. Until now, we were discussing the concepts. From this point onwards, we will start building our own things. And trust me, the best way to learn about AI is not by reading about it. It is by building it. So let's begin our first coding session. Build an AI project, we first import the libraries. Think of libraries as toolboxes. Imagine you are building a house. Would you manufacture your own hammer or screwdriver and drill machine? Probably not. You simply use the existing tools. Similarly, in Python, we use the libraries built by thousands of other developers across the world. Today, we will use three main libraries. The first one being NumPy, the Pandas, and the Matplotlib. These three libraries form the foundation of data science and machine learning. So let us start by importing them. Welcome to our Google Colab session, and we will click on the first line, that is code, and we will write import NumPy as NP, NumPy as NP. So whenever I am going to write NP, it is going to call the library of NumPy. Second, I am going to import the library of Pandas. Similarly, import Pandas as PD. And lastly, import Matplotlib as PLT. So whenever I am going to write PLT, it is going to fetch me the library of numpy.pyplot. Whenever I am going to write PD, it is going to fetch me the library of Pandas. Now let us run this particular block of code so that the Google Colab fetches all the existing libraries. Now this green tick here means that this particular cell session has completely run. Now we will move on to the next line of code in which we are going to discuss the first library, which is NumPy. NumPy stands for numerical Python. So let me first write it here so that you guys understand it in better way. NumPy. NumPy. Control enter to run this particular block, and I am going to add a code so that when we are going to write our coding in this particular line, and whenever we need a text, we are going to write it in markdown format. Whenever we deal with numbers, arrays, matrices, vectors, or any mathematical operations, NumPy becomes a very extremely useful tool. Remember, in our previous session, we discussed about datasets. Internally, many datasets are represented using form of arrays or matrices. So let's first of all create a simple array. So for that, I am going to create an array named numbers equals np.array. So it is going to form me an array in which I am going to write about 1, 2, 3, 4, 5. Now, whenever I have to print this particular array, I am just going to write print, and inside print, I am going to write the name of array, which is numbers. I'm going to copy it and I'm going to paste it and control enter to run this particular cell, and it is going to print me my array, which is 1, 2, 3, 4, and 5. You can see that Python stores all the values together as a NumPy array. Now, I suppose want to multiply every number by 2. Instead of writing loops, I can simply write numbers into 2. Correct? So whenever I want to write it, I am going to just write numbers and star and 2. Okay, and instantly every element gets multiplied by 2. As we can see, 2, 4, 6, 8, 10. Right? Now let's move on to the second library, which is about pandas. Pandas helps us to work with datasets. So whenever you download a CSV file, let's say from Kaggle, most likely we will be using Pandas to read and process it. So now let's create a simple dataset using Python. Let us create a student's data in which we will be storing some values of names and some values of the marks they have scored in exams. And then we will be converting it into data frames. So first of all, we will be creating a text box in which we will create the title, that is Pandas. And in Pandas, we will create a code, that is student underscore data. And in student underscore data, we'll be creating the first column, which is about name. And in name, I'll be writing in an array the names of students. The first name, let's say my name, then a friend of mine, then again another friend of mine. Okay, let's say I wrote name Sahil, Amol and Yash. And after this, I'll have to write their marks as well, creating a new column which is about marks. The marks, okay. And in marks, I'll be writing, let's say I secured 85 marks, Amol secured 92 marks, and Yash secured 84 marks. Okay, Control Enter to create this particular student data, and then I'll be converting it into the data frames. So what exactly are data frames? So data frames can be imagined as similar to Excel sheets but inside Python. Okay, so to create the data frames, we will be writing df. So this creates the data frames, which is by pd.dataframes data frame, and inside this I'll be writing student data. Okay, now the data frame has been created. Let's say when I write df.head, it is going to print me first few values about okay, yeah, it is going to return me the first few values. The first value is about Sahil, and I have secured 85 marks. Amol has secured 92 marks, and Yash has secured 84 marks. Okay, now these have been printed in rows and columns, and almost every machine learning project begins with loading of data sets into Python or Pandas using data frames. So Pandas is one of the most important tools that we are going to ever learn in Python. Now comes the third library, and third library is what we discussed. It is Matplotlib. Matplotlib. Okay, and as the name suggests, Matplotlib. So this library is going to be used to make few plots or graphs or charts or anything that comes in our mind when we are going to represent all the data. Okay, as humans can understand pictures faster than numbers, and that's why data visualization is most important step in data analytics. So now let's start by creating few simple graphs. First of all, we will create few values on x-axis, we will create few values on y-axis, and then we will plot them using plot dot, then we'll be writing x and y. Okay, and finally we'll be using the same trick to give us the values in the graphical form. So for that, we will be writing here, creating a new code line, and here we will be writing plt.bar, and in this we are going to first of all create the first x-axis in which we are going to fetch the name column from the data frame. So here df, and with df I am going to write here about name. Okay, and for y-axis I'll be needing the marks, and for that again df, and here marks. Yes, marks. Okay, and let's say I want color, color, and let us set it to green. Okay, and after this we'll have to add title to the axis as well. Okay, for that plt dot x label, titles to the axis are known as labels. So x label X label, and in this I am going to write student name. Okay, student name. And similarly for y-axis as well, we'll have to write the same thing, and then for title as well. So for y label, we'll have to write marks, and for title, title, we have to write, let's say, student performance. And final line, we'll have to show the graph. So to show the graph, we'll have to write plt dot show and complete. Okay, when I press Control and enter, it is going to run the code, and it is giving us the performance matrix, the performance graph, as we can see here. Okay, I'll zoom out a little bit. So title is student performance, student name on x-axis, the marks on y-axis, and it is represented in green. Let's say if I change the color green to, let's say, sky blue, Control enter, it is going to change the color. Let us I change performance, and I write matrix, performance matrix as title, marks secured in y-axis, and student name in the x-axis, and Control enter. It is going to show performance matrix as the title, then marks secured on y-axis, and student name on the x-axis as it was. Okay, so that's how we play with the Matplotlib library. Yeah, and for example, how can this Matplotlib be useful? Because patterns are becoming visible using Matplotlib. So for example, whenever we have to chart some sales trends or weather data or stock prices data, or let's say student information or performance, as we did in here, this all becomes easier to understand through the graphs. And as AI engineers, visualization becomes most important skill that is to be used. Now, moving on from this, we are going to enter the world of deep learning. This was just data analytics part or simple data science part that we had to know as prerequisite to what we are going to understand later on. Now we are going to create our first neural networks. So I want everyone to pay attention, because this is going to be the first neural network. And today we won't train on it, we will just create it and inspect it. Now let us start by creating the first library, which is TensorFlow. Okay, let's say we write the title. Title might be like first neural network. Okay, first neural network. Let's say we keep N as capital N. Okay, we'll write our first line of code in which we will be import TensorFlow as TF, enter. Now, TensorFlow is one of the most popular deep learning frameworks in the world, and it was developed by Google. And many modern AI applications are built using the library TensorFlow. Now, let us create the first neural network, which is the model. And we will be writing model equals tf.keras.sequential, sequential, and in this we will be creating tf dot keras dot layers layers dot dense, and we are going to create 10 neurons. And let's say we apply activation function as relu. So what is relu? I'm going to tell you tf dot keras dot layers dot dense, and then output is going to be 1. Okay, so this particular line of code might look scary to many newcomers, because this basically is scary, because first of all we are defining a model, and in model we are defining something known as keras and sequential. So sequential means that the layers are connected one after the another. In the previous video or the previous section where we discussed, there is an input, there is a hidden layer, and then there is output, just like neural networks diagram we saw in the earlier PPT presentation. and then we are using here 10. So this 10 basically means that we are creating 10 different neurons. Neurons can be understood as small processing units, just like the neurons which are in our brains, correct? And now we see something known as this ReLU, as I told you. So what exactly is ReLU? ReLU is activation function. Think of it as it is a decision making function. It helps the neural network understand and learn the complex patterns that are being created. And finally, we are creating this one neuron, which is going to be our output neuron, which is the final prediction that we are going to do. Now we will create a model summary. So for that, model dot summary, and it is going to print us the summary of models. Invalid syntax. Okay, there should have been a comma here. Control enter. It is running, executing, and yes, it has completely executed. The model was sequential. That means it is going to first of all take input network, then it is going to add it in hidden, and then we are going to get the output. There are total two layers that we have applied. The first and second both are dense layers, and these are going to be the parameters which are going to be trained on it. Okay, and just like that we get the summary. So after summary, by this we are getting to know how many layers are there, total number of neurons that we are going to train on it, and in future sessions when our network becomes larger, this summary will be coming very useful. And for now, congratulations, because you have first of all built your first neural networks, and welcome to deep learning. And now let us create a basic machine learning project just so that we get started. And the problem statement for that is very simple. Suppose we know how many hours students have studied, and according to that, we know how many marks they are going to score. Can a machine learning relationship create the relationship between the hours of study and the marks that the students might get? So for that, let's see. Our data should look like, so let me create a text here. Our data should look like study hours, HOURS, as 2, 4, 6, 8. And the scores, let's say marks, they look like for 2 hours, let's say the person is getting 30 marks, for 4 hours 50 marks, 70 marks for 6 hours, and for 80 he is scoring 90 marks. So can the machine learning model be able to discover this pattern? So for that, we first of all create our input values, which is study hours. So let us start with the code. Here I am going to write study underscore hours equals np.array, and in array I am going to add all these as the timestamps 2, 4, 6, and 8. Okay, and then I am also going to add here marks. Okay, and marks are represented as, again, the array np.array, and here I am going to write for 2 hours he secured 30 marks. Okay, then 50 marks, then 80 marks, 70 marks, and last 90 marks. Okay, and now we have to print. Let us see if it is going to print it correctly or not. So print, and in print I am going to write here about study hours, HOURS. Okay, study hours, and after this print the study hours, STUDY underscore hours. Okay, so this is going to print about us the study hours. Let us see if this runs correctly. Yes, it has run correctly. The study hours are printed in this following order. And now next we are also going to print the marks similarly. Okay, control C and here control V. Here I am just going to change the study hours to marks, marks, and this study hours as well to marks. Control enter. It is going to print us the study hours and as well as the marks. Now we are going to create a model. So let's say for that we are going to use linear regression. Okay, so let us create the model. Here I am going to write create model. Okay, sorry, control X. Here I'll have to use text box, create model. Okay, and in model I'll have to write lr underscore model as linear regression. Linear regression model will be created by this. Okay, I guess the linear regression model has not been defined. Okay, so for that we will have to import the model, linear regression model. So how do we import? We just write here sklearn.linear model and write linear regression. Control enter. It is going to create. Okay, the execution has been completed. The model has been created. Okay, now we will begin with training the model. Okay, so let us create a new cell and inside this cell we will write training model. Okay, okay, yeah, and new code. Here I am going to write lr underscore model, linear regression model, and in this I am going to fit it with study hours and the marks. Okay, and then I'm going to print if the model runs successfully. I'm going to print here that the model train success. Okay, control enter. So it is going to train the model. Okay, I guess I forgot comma here. Okay, this particular thing should be inside this. Yeah, control enter. Yeah, there seems to be one more mistake. Okay, let's see. It is giving us the same error. Okay, so the array needs to be reshaped as -1 and 1. So let us go above to the model. Yeah, to the study hours, and we need to reshape it from -1 to 1. So for that, we will click here and write dot reshape it as from -1 to 1. Okay, yeah. So we will rerun everything. And yeah, the model has successfully been trained on the given data, which was the students' hours and study hours and their marks. Okay. So now we are, let's say, going to predict it. So let us create a new text column, and in this we will write predictions. Okay, and in new code we will write, for example, I take hours equals 5. So predicted underscore marks will be lr underscore model dot predict. So this is the function which is going to be used to predict the marks, and as inputs I am going to take the inputs as hours. Okay, so round brackets, and in that the two square brackets hours, correct? And then I'll be printing print in print Okay, so in print, I'll be printing predicted marks, predicted marks for in here HOURS, predicted marks in hours. Okay, and then print, and in print we will be writing predicted marks, predicted underscore marks, and for that I'll have to submit 0 here. Okay, so just okay. Okay, this is giving us some error. Okay, there is some invalid syntax here. This should be inside. Yeah. Yeah. So predicted marks for 5 hours is going to be 60 as we saw in the earlier. Now let us create some more prediction. Okay. So let's say we take something more predictions, more more predictions. And in this I write a new line of code or block of code. Let's say test hours, test underscore hours, test underscore hours. And in this I write it as in square brackets. Let's say I add another square bracket, 1 comma 3 comma then 5 then comma 7 then comma 8, sorry, 9. Yeah. And inside this I write predictions predictions equals lr underscore model dot predict and test hours. Okay, not like this, test underscore hours. Oh, so many. We just need this test hours. Okay, so it is going to give me the test hours, and then I'll write about predict print, and in this I'll be writing about predictions. Okay, now for h comma m in zip, let's say we create test hours and predictions. Test underscore h is the hours and m is the marks. Okay, test hours comma predictions. Okay, the h here stands for test hours and the m here it stands for the predictions. Okay, so by entering into the loop I'll have to put this colon here and print. I'll have to print, first of all I'll have to print the study hours. So for that f and here study hours equals, and in curly bracket I'll have to write h of 0 first of all, and then I'll have to move on to here dash and arrow with predicted marks equals m equals inside curly bracket m, and with m I also want them to be up to 0.2 decimals, so 0.2 decimals f. Okay, and the loop is closed. When I run this particular cell block, it is giving me some error for h and m. Aja, test hours, I took here test hours, test hour. Okay, so the study hours, okay, let's not say here study hours, test hours. Okay, enter. Yeah, for test hour 1, the prediction was 20 marks. For test hour 3, it was 40 marks. And so we continue up to test hours equals 9. So that gives us 100 marks. Correct. Now let's move on to visualization stuff. So text, and here I'll write about visualization. And in this, I'll create a new code block. And inside code block, I'll also have to write plt.figure figure figure, and let's write figure size equals, let's say, 8 by 5. We take the canvas as 8 by 5. Okay, and then plt, let us draw scatter plot. Plt dot scatter, plt dot scatter, and in scatter plot let us write here. So first of all, study hours, study underscore hours, study hours. Then we write about marks, marks, marks. Then we write s equals to 100, and then we write label as actual data, or let's say just write data. Okay, now we are going to plot it. So this, by this we have created a scatter plot. Now we are going to plt dot plot. And what are we going to plot here? First of all, study hours, study underscore hours. Then we are going to lr underscore model dot predict. So second option, predict. And in this study hours, study underscore hours. Okay, now we are going to comma and enter. Here line width, because we also need to define the width for the scatter plot. And last but not the least, label here as regression line. Okay, this is going to give us the plot for that thing. And let's say plot title should be say study hours versus marks, study hours versus marks. Then let's say we'll just copy this line. Okay, we'll copy this line here. Let's say we write x-axis, y-axis. Okay, so x label label, and here y label. Okay, study hours here, and marks we continue here. Yep, and we'll also need a legend, plt.legend. Okay, and then plt, we also need to show it in a grid format, plt.grid, and grid should be set to true. And last but not the least, we have to plot it, plt.show. By this we will be able to see the plot. Let us run this command, and yeah, we can see the line graph. For 2 hours the student secured 30 marks, for 4 hours the student secured 50, for 6 hours he secured 70, and for 8 hours he secured 90 marks. So this was how, and this is the legend that we discussed it here. Yeah, this is the legend that we talked about. So dot stands for data and line stands for the regression line. So yeah, that's all for today, guys. And one more bonus challenge for you guys. If you are able to complete everything up till here, I would like you all to build something more out of it. Just like let's say approximately someone studies for 10 hours. How many marks can he get? So if a person is studying for complete 10 hours, he should probably get 110 marks if we look at this particular graph. But is getting 110 marks possible? No, practically it is not, right? So to do these particular things in data science, we need to understand the domain knowledge. That is the most important thing. Machine learning is powerful, no doubt, but the domain knowledge is equally important. So the machine can learn the patterns And human knowledge is important to provide the context to the knowledge that machine is learning. Together, we are able to build the intelligent systems. So what did we learn today? First of all, we discussed about NumPy, which was used for numerical computing or calculation stuff. Then we moved on to Pandas, which were by which we were able to handle the data sets. Then we talked about Matplotlib, which is used for visualization purposes. Then we saw TensorFlow library, which is used to create deep learning models. We talked about neural networks, linear regression. We tried training and testing. Then we moved on to data validation as well. And most importantly, we first of all built our very own first AI project. And that, guys, is the huge achievement. So with that, we come to an end of the first day. I hope you enjoyed this session very well and got a glimpse of how exciting the artificial intelligence can be. If you found this session to be useful, do leave your questions and doubts in the comment section. I personally go through student feedbacks and try to answer as many questions as possible. Also, don't forget to like the video, share it with your friends and subscribe to my channel because many more exciting sessions are coming very soon. And once again, I would highly encourage you to explore the Ingiverse community. All the course recordings, quizzes, learning materials, certificates and future technical content will be available there. Ingiverse was created with a single goal to help the engineering students prepare for placements, get examinations and semester studies and technical careers as well. Apart from this deep learning series, you can also find my content across various domains. On Sahil at Work YouTube channel, you will find detailed courses and discussions on algorithms and problem solving, data science with Python, microcontrollers and microprocessors, signal systems, radio astronomy, and many other engineering and technological topics. So keep learning and keep building, keep experimenting because the future belongs to those who create it. And thank you everyone. I will see you in the next session where we will start going deeper into mathematics and the foundations of deep learning. Until then, happy learning and happy coding. Adios.